So in the year 1820, there was a scientist, Hans Christian Oersted. So Oersted experiment you have also seen in your 10th standard probably, if you are from CBSE curriculum, or other boards also mention it specifically. Well, then in this experiment, what he wanted to show was that actually when he had a wire and when current was flowing through this wire, it started behaving like a magnet. How did he prove this? Well, he had a setup like this and he connected it to the cell. Well, in the vicinity, there was a magnetic compass. And what he saw as the current started flowing in the wire, the magnetic compass started getting deflected. And as we know from our basic understanding of magnetism, that a magnetic compass will only be affected by another magnet in the vicinity. And why it is getting affected? Because there will be a magnetic field because of that current carrying conductor, isn't it? Some basic idea we already have about the magnets, right? From our lower standards, we have studied about magnetism. So we know that how a magnet behaves, even we have played with it at some point of time or the other. So it's not something new to us, right? So what we felt is that because of the current which is flowing in this conductor, something is going on, some weird phenomena is going on, which is actually responsible for making this particular magnetic needle getting deflected in a particular orientation. He also observed that if he increased the value of the current, the deflection was more. And to his surprise, when he changed the direction of the current, what happened then? When he changed the direction of the current, and this is a dual switch where you can, just interchange the direction. What he saw, that the direction of deflection of the magnet or the magnetic needle also changed. It was now opposite. Okay, so what did he conclude from this? What do you conclude from this experiment? It means that somehow this conductor through which the charges are moving, this conductor is behaving like a magnet. This current carrying conductor is behaving like a magnet. So all this while we have talked about different effects of current. We know that current has got heating effect. If we pass electric current through heaters, we generate heat. If we pass current through tube lights or probably bulb, let us say, we get light. What is special about this particular phenomena? What is so special about it? Why so much of fuss? Well, at that point of time, it was really a achievement that everyone looked up to. And Oersted was treated like a superstar in the scientific fraternity. Actually speaking, when you think about it, that a current carrying conductor behaves like a magnet, can it have any kind of an implication? Because we have seen that yes, current can be used to obtain heat or light, but in this case, we are using current to obtain magnetism. And this is called as the magnetic effect of current. As we know that if the current flows through a heating coil and we get heat, we say that it is the heating effect of current. We have also known about the chemical effect of current. In electrolysis, obviously you must have studied in chemistry for sure. But over here, when you pass current through a conductor, you are getting the effect of magnetism. And this is called as the magnetic effect of the current. Well, to give you some emphasis of what this experiment behold, well, the ceiling fan that you use works on a similar principle. The motors work on a similar principle. The drum of your washing machine works on this principle. And even the instruments that we had seen, the galvanometer, the voltmeter, they all work on this principle. That is the magnetic effects of the current. So once this experiment was conducted, people were very curious, and even the scientists were very curious. They wanted to know more and more about this. Because since this particular statement or this particular experiment arrived at the podium, it was thought that electricity and magnetism are two different branches of science which have nothing in common between them. Although there was some kind of speculation that they have certain things in common, but nobody was able to establish the relation between electricity and magnetism. And this experiment in 1820 by Oersted was the break-even point which gave birth to a new branch of physics in itself, and this branch, what we today know as electromagnetism.